Sturm, and in this video segment I'm going to go over how to identify minerals. So there are over 3,000 minerals in the world, and we need a way to classify them. Now before we get started, I want to talk to you a little bit about safety precautions with handling minerals and with some of the rocks. I do have some things written on the blackboard. I'm not sure if it will show up on the video, but I'll read through them just so I'll touch all those points. So first of all, for safety, always wash your hands after handling the minerals and the rocks. And the reason is that some of the minerals, like this one, this is sulfur, a lot of people can be allergic to. So if you are allergic to sulfur, sulfates, sulfides, some of these minerals that you're going to be handling do contain those. So be aware of that. And two, some of the minerals contain hazardous materials. So not only can you be allergic to them, but they can also be hazardous. One of the minerals that you're going to be looking at is galena. Galena is the scientific name for lead. Now we know that lead can actually be very poisonous if ingested. So this is another reason we want to wash our hands. Galena also happens to contain very high amounts of sulfur. So this is kind of a double whammy with the galena. So definitely when you're done with the lab, make sure you wash your hands really well. The next safety precaution is that if you're going to be using the acid, so in geology we use a diluted hydrochloric acid. You can also use something like lemon juice. You can use something that has an acidic quality to it, and you'll often get very similar results. So lemon juice is another option, but diluted hydrochloric acid, this is a 10% solution of hydrochloric acid. When using this, never, ever, ever put the acid on anything that is yellow or that is dark. And the reason is that, in particular for sulfur, when you combine acid and sulfur, you create mustard gas. Okay, mustard gas, it'll actually smoke a little bit, and it's extremely hazardous. It was used during World War I, and what happens is if you breathe it in, it can actually melt your lungs. So do not ever put acid on anything that's yellow, and do not put it on anything that's dark, because the dark minerals often contain sulfur. So we're only going to be using the acid on minerals that are light and clear in color, or they might be gray. So this mineral, this is actually dolomite, so it's pink on this side, and on the back side we have limestone. So limestone that we'll be looking at tends to be gray in color, and once you learn to identify them, you'll be able to pick up what you can and can't put the acid on. But do not ever put any acid on anything that's black or anything that is yellow. And we have several minerals that are those colors. So for instance, this is pyrite. Pyrite looks like gold, and it's called fool's gold. This also contains extremely high amounts of sulfur, so don't put the acid on this either. And then the next thing, and you'll get a little chuckle out of this, but a lot of geologists use taste tests. So yes, you can lick some of the minerals. The only ones that you can lick without ingesting anything hazardous are those minerals that are clear or even white in color. Do not do this with any dark minerals, none of the yellow minerals. But so for instance, like this one, you can definitely lick it, and taste is a specific property for this mineral. This mineral is halite, and halite is more commonly known as table salt. So it's going to taste salty. So there are actually several minerals that make up different kinds of salts, but halite is the most common one used in geology classes, and it's perfectly safe to lick. One of the unique properties of salt is that it kills all bacteria on it. So bacteria cannot live on this piece of halite. So when you lick it, any bacteria that's in your mouth are killed instantly on that rock. So if you passed it to somebody else and they licked it, again, they would not pick up your bacteria because the bacteria would already be dead. So keep in mind what you can put acid on and what you can lick. So those are your basic safety precautions. And again, remember, wash your hands at the end of every lab. So to get started on identification of minerals, we look at properties. So properties are those characteristics that help us identify minerals. One of the primary properties that people use the most is color. So color is the first property that's used most frequently. Now, it's important to note that there are some people that are colorblind. So if you do have color blindness, you may see this chunk of sulfur as being green. It may not be a vibrant, bright yellow that other people see. And so if you're colorblind, you're going to have to figure out the color of the rocks according to your particular way you view the world, the way you view color. So for instance, this is sulfur, and again, it is a bright, vibrant yellow, extremely bright. Other people may be red-green colorblind. So this particular rock, this is a type of quartz. This is rose quartz, and this is kind of a pink color. Very pink color, like, princess pink. And, but some people may also see this as has a green tone to it. So it's going to depend on how you see color. But color is a very common property, and it can be very identifying. So for instance, we have two minerals here that are both purple in color. Now there are very few purple minerals. Out of all the 3,000 minerals, very few of them are purple. So right away, when we see a unique color, that can eliminate the vast majority of minerals. There's probably less than 10 minerals that are purple. And of those 10, only 2 of them are really common. So these are the 2 most common. These are different minerals. They're not the same mineral. This one, in this hand, this is amethyst quartz. So this is the purple variety of quartz. In this hand, this is fluorite. And so we have 2 minerals of the same color, and when we encounter these, if we have these together, so if you had a test and you had to distinguish which was the fluorite and which was the quartz, obviously we wouldn't use color as a property to identify it. We'd use one of the other properties. And in this case, we would use hardness. These have a different hardness. So, as I mentioned before, some minerals have many different colors. So that fluorite comes in purple, green. This chunk is actually a mix of yellow and purple. So those are your most common colors: yellow, purple, green, and actually clear also for fluorite. And then quartz comes in many, many, many different colors, really every color under the rainbow. And typically for quartz, each color has a unique name. So amethyst is the purple variety of quartz. This is citrine. So this is the yellow, kind of a dark golden yellow variety of quartz. This is just a natural crystal quartz. It's a clear to milky quartz. I showed you the rose quartz. Rose quartz is a pink. Also have example of individual quartz crystals. So quartz grows in this prismatic form, that's its crystal habit. And this is a smoky quartz. So it's kind of a dark brown quartz. So we have several that come in different colors. And so in that case, that color can help you identify what the mineral is. The next property is called streak. Streak is the mineral in powdered form. So how do we get that? Well, you should have a little streak plate in your kit. This is a little white ceramic tile. You can actually use any ceramic tile. White is normally chosen and it's unglazed, because then you can actually see the color on the rock. So for instance, if I were to take galena and I wanted to test the streak, I am not going to do this. I'm not going to hold the plate and then press against it. The reason is your hand doesn't provide enough resistance, and the plate can break in your hand and you can get cut. So whenever you use these, always put the plate down on the countertop, hold it down, and then take the mineral and go across it. So in this case, galena produces a dark gray to black streak. Now, you may think, oh, well, why do I have to streak it? I know what the color is going to be. You know, I know that if I streak this dark smoky quartz, it's going to be brown. Wrong. Just because it's a particular color does not mean that that's the color that the powdered form is going to be in. So if I take the smoky quartz and try and streak this, first of all, quartz is very hard, so it may not powder. But typically when it does, it's going to be white. You're not going to see any of the smoky color in the streak. So do not assume that the color of the rock is going to be the same as the color of the streak. But each mineral, each mineral has a different color of streak. And of course, all of these minerals then make up rocks, so they're the building blocks for rocks. And so when we're looking at streak, again, you're looking for the unusual. So there are several of them. For instance, the pyrite. Pyrite can vary. When you have a large chunk of rock like this, one thing to also note if you're doing either the streak or the hardness test is you want to identify the crystal you actually want to test. The reason is a lot of times these minerals will grow on top of other rocks. So if I want to check for the streak for pyrite, I want to find a pyrite crystal and then actually test that. I do not want to test this rock that's on the back because that's a completely different rock and it's not pyrite, so it wouldn't give you the correct answer. So a lot of times these minerals that have a lot of sulfur in them, when you streak them, two things you might get. Some of them do produce a yellow streak. Now the minerals that you're looking at don't have that, but there's one called sphalerite. It's a very dark mineral, but it does produce a light golden streak. The other thing though, any of the minerals that you streak that have sulfur in them, if you smell the plate, you'll notice it will smell kind of like rotten eggs or fireworks. That is the sulfur that's inside of that. You've powdered that sulfur. So the streak can also help you with a special property. Special properties include magnetic, smell, and taste. So the streak plate can help you with that. So the next one is hardness. And when we're testing for hardness, you can memorize numbers. I typically don't make my classes do that. We use our fingernails or pennies, because a fingernail and a penny are about the same hardness. Now I'm referring to natural fingernails from someone who eats a good, nutritious diet. No gel tips or acrylic nails, because those would be harder, but natural fingernails. So fingernails and a penny are right between 2.5 to 3 in hardness. The next step up would be either a metal nail file, which this is just the only one I found right here. It's a little bit rusty, but metal nail file, a pocket knife, or if you have any of those scissors that are like the Fisker's scissors, where they're a metal scissors, they would also be steel, and you can also use those to test hardness. So these are right around a 5.5. So all those around a 5.5. And then the last tool we use for hardness is a glass plate. And just like your porcelain streak plate, in order to use this, do not hold it in your hand, because it will definitely break. And of course, we know what happens when broken glass comes in contact with skin. You get lots of blood all over. So again, you would put the glass plate flat on the countertop, and you would select the mineral that you want to test. I happen to know that quartz will definitely scratch glass if I press hard enough. Now glass has a hardness of around 6.5. Quartz has a real similar hardness. It's about 6.5 to 7. So for quartz, sometimes you have to press really hard on the glass in order to get that straight, get a cut in the glass. And so that's what we're looking for. We're looking for pressing really hard, and you're going to actually scratch the glass. So you put the glass plate down, and then you scratch across it. And when you do that, you'll see a line that appears on the glass. You want to be sure that you actually scratched the glass and you didn't just powder the mineral on the glass. So you want to take your finger and go across that line. If it's powder, the powder will wipe away and you'll see it wasn't scratched. In this case, it definitely scratched the glass and it left a scratch behind. So that's how we use the glass plate. For the nail file, you can do one of two things. You can either take the nail file or your metal steel and you can try and scratch the mineral, or conversely, you can take the mineral and try and scratch the nail file. So I know that quartz will definitely scratch the nail file, but the nail file will not scratch the quartz. So quartz is harder than the nail file. Now some of the other minerals, we have potassium feldspar. This is a pink mineral. It's considered a salmon color. It's kind of a light pink color, and it has what looks like little veins that are running through it. So this is the typical color for it. So again, we can use color to help identify. And then we also look at how the crystals have grown, and it has that kind of veining that goes through it. This is about the same hardness as the steel, so you should be able to either scratch one or the other with it. This will not scratch glass though. It will definitely not scratch glass. And then the same with your penny or fingernail. There are some minerals that we have. So for instance, this is talc, that you should be able to, if you have a fresh piece of talc, you should be able to take your fingernail and scratch across it. The reason I say fresh piece is that when we're looking at hardness, the minerals that are at the bottom end of the scale, the ones that are soft, they pick up the oils and the dirt that are on our hands. This is another reason to wash your hands frequently. And because they're soft, that dirt and oil will embed in the mineral. That mineral then becomes harder because you're adding chemicals and other mineral dust to this. So it's going to become harder over time as you handle it more. So in a brand new fresh piece of talc, you should definitely be able to take your fingernail and easily scratch it. And we have several minerals that are like that. This one is not talc. This is called kaolinite. It's a type of clay, and it's very soft. A lot of people mistake this for talc, or they mistake it for chalk, like what I've used to write on the blackboard, but it is not. It is clay. So with a penny or fingernail, those should be very easy to scratch. You just need to understand that those minerals can take the oils and the dust from the other minerals off your hand, and it will embed in there because they're so soft. So that's your basic hardness. We go from the harder quartzes that we have here. I believe quartz is going to be your hardest mineral that you have. Yes, quartz is going to be the hardest mineral you have. And the talc will be the softest mineral you have. Now, since I'm holding up the talc, I want you to know that talc does come in different colors. It can come in kind of a greenish color, sometimes maybe even a light blue color, and then this, of course, is the white cream color. Okay, the next property that we're going to look at is crystal habit. And so I've shown you a couple of different crystal shapes. So a crystal habit refers to how the mineral is formed. So what happens is these minerals are formed from fluids. So we have fluids with little tiny atoms that are floating in the fluid, and the atoms begin to move to a structure, and they attach to a structure. Well, as they attach, those atoms are going to form patterns. And those atoms are going to build upon each other to create whatever mineral is being created. So each mineral has a different pattern of atomic structure. So in this case, this is a quartz. It has a prismatic structure. Now you're only going to see this prism form, like I have with the smoky quartz or like this clear quartz. And you can see how it sparkles. We have lots of different prisms on this big chunk of quartz. You're only going to see this if the mineral has room to grow. If it does not have room to grow, and it is very crowded, then you're going to get what's considered a massive habit. And so when it's massive, that means all the crystals have grown together and you can't see the individual crystals. So this is also quartz, and the rose quartz would normally look like the smoky quartz if it was individual crystals. But this contains just hundreds of crystals that have all grown together. So we don't see that individual prism. So we also look at some other shapes. So while this is a prism form, this one is a rhombohedral form. So rhombohedral is a parallelogram. So it's a four-sided object, not at 90 degrees. So it's a parallelogram in 3 dimensions. That's what a rhombohedral is. This is one mineral that we're going to see not only in the mineral section but also in the sedimentary rock section. It's a very important mineral, and it's called calcite. Calcite is very common. It actually is a building block for limestone, and of course limestone is deposited in oceans around the world. Here in the United States we have hundreds upon hundreds of feet of limestone. Particularly in the Midwest we have a lot of limestone. And that limestone formed many millions of years ago when our continent used to sit on the equator. So limestone forms in warm tropical waters. And so calcite takes this rhombohedral form. So when you have a pure calcite, if I were to break this, part of a crystal habit is that when you break it, it's going to break into smaller pieces. Those pieces are going to look just like the big piece. They're going to be rhombohedral in shape too. Another example of this is the halite, the table salt. If you're at home, I want you to pour out some table salt and get a magnifying glass and look close up to see the shapes you see on that salt. You'll see a lot of them that have the cubic form. So halite has a different crystal form and it's cubic. So that means we have we have 4 sides and they're all at 90 degrees. So that's a cubic crystal habit, and the atoms arrange themselves to grow in this form. But again, if I break it into little pieces, many of those pieces, you're going to see these right angles on those pieces. And that will help you identify that cubic crystal form. Another type of crystal habit is laminar. Laminar is when crystals grow in these flat sheets. So this is actually muscovite. This is one of your minerals, and it grows in these flat sheets. It comes in big chunks like this. Biotite is another one of your minerals, and both of these have the same crystal habit. They grow in these sheets. If you pull off a single individual crystal, so this is one crystal, sometimes on the muscovite you can see through it. Muscovite was actually used by pioneers in areas of the United States that contain muscovite. The pioneers, when they were building their log cabins or their sod cabins, they would use this for window glass because glass was very hard to come by, you know, in the 17 and 1800s. So they would use that for window glass when it was available. Biotite, when you pull that off into individual sheets, it's very dark. So biotite, the difference between biotite and muscovite, biotite is brown. And so the individual sheets are going to be dark brown to even black in color. They're a lot more difficult to see through, but it will pull off in the individual sheets. The muscovite is going to be a light, they can be cream to even a greenish color. But again, those both have a different crystal habit form, and it's these individual sheets. So we have these are 2 separate crystals, and that's the way the crystals grow. So then the next thing we look at is luster. So luster is how a mineral appears in reflected light. Ooh, it sounds like I got some construction going on. I hope you guys don't hear that. So how a mineral appears in reflected light. So when I hold this chunk of quartz up, and we have lots of individual quartz crystals, what you should see is that the light is reflecting back to your eye. It sparkles. So that is called vitreous. Vitreous is when we have a lot of light reflecting back to the eye. As opposed to something like the sulfur or even this particular chunk of fluorite. When I hold this piece of sulfur up and move it around, there's no light reflecting back to you. So when there's no light at all reflecting back to you, then it's called dull. So it is called dull. A lot of the luster terms relate to how we view a mineral. So for instance, on the talc, you get a little bit of light that reflects back to you. It has a little bit of shine to it. But because the color is white and creamy, a lot of people would call this a pearly luster. So pearly. The most common ones you're going to use are going to be vitreous and dull. You can also have, I'm trying to think what some of the other lusters are. Those are your primary ones. You're going to use a lot of pearly, dull, and vitreous. So here is a pearly. This is a type of gypsum. This is another type of gypsum. This one is dull. And then this is a third type of gypsum, and that reflects light really well, and that is vitreous. So sometimes one mineral can come in different forms, and so we can have different types of luster depending on the crystal habit. So luster is a little bit more subjective because it varies by the actual sample. So you can have a quartz sample that is very dull, it won't reflect. Or you can have a quartz sample that is very vitreous, it reflects lots and lots of light back to you. All right, the next one is specific gravity, and this really only is used for very specific minerals. So specific gravity means that when I pick up a rock or mineral, and when I look at it, before I pick it up, your brain is going to register, how much does that weigh? How much effort do I think I'm going to have to take to pick that rock up, or that mineral up? Because we also use specific gravity in rocks too, so this is one you'll need to know for rocks. So if I think, oh, well that's going to be, an average weight for this size of object to pick it up, and if it's what I expect it to be, then it just has a normal specific gravity. But if we have a sample, like this is magnetite. And magnetite, as you may guess, is highly magnetic. So that if you have a magnet, you can it'll stick right to the magnetite. So this is, we find this a lot with iron ore. But magnetite has a higher specific gravity. So that means when I pick up this small rock, it's heavier than I expect. It's like, oh, it weighs more. Another one that has a high specific gravity is galena. So galena, as I mentioned, is lead. Of course, lead weighs a lot. And so for this size, this is a very small piece of galena. So you normally would think it wouldn't weigh very much. Matter of fact, I have a piece of calcite here that is more than twice the size of galena. And they're about the same weight. So the calcite is twice as big, maybe even 3 times as big as the galena, but they're about the same weight. So that tells me that the specific gravity for galena is higher, because if it was the exact same size, it would definitely be heavier. So specific gravity, and the formal definition for specific gravity is an equal amount of displacement of water for the equal volume. So if this is 1 milliliter in volume, if I had an equal amount of water, then a normal specific gravity would mean they weigh the same. But when you have something of high specific gravity, that means it's going to displace more water. So that's the formal definition. The easy definition is you just weigh it out in your hands. And then I mentioned special properties. So I discussed magnetism. So some minerals are magnetic. There's not very many. So this is a really distinguishing property for those minerals that are magnetic. And then smell, I mentioned the smell. So typically all the minerals that contain sulfur are going to have some smell to them. Now you may have to scratch them, or you may have to use a streak plate to get that smell, but like I can still smell the sulfur from testing the galena and the pyrite. But sulfur will definitely have a smell. And then we have taste. And I already mentioned the taste for the halite. So it does taste like salt, and it's perfectly safe to taste test the light or white colored minerals. There's nothing harmful in those. So those are your basic properties, and we're going to use those to identify the minerals. Now, the minerals that are on your list. I've already mentioned a few of them. So we have biotite and muscovite. These are both very vitreous in luster, and I mentioned that they have this unique crystal habit where they grow in sheets. There is also another type, these are called micas, by the way. So when they break down into real tiny pieces, they're called a mica. And there's another type of mica that is purple in color, and that's called lepidolite. It's very, very pretty. So we have those two. Dolomite. Dolomite typically does have some calcite in it, but it has some other minerals also in it. And there are different forms of dolomite. So the dolomite that I have here is actually the mineral form. So this one, some of these are stained a little bit, but the crystal form of dolomite, they tend to be pink crystals, and they kind of look, they're always real tiny like this. And so sometimes people might think they look maybe like Rice Krispies or, you know, some small pink crystal. Now with dolomite very frequently, and in both cases on these, you'll see the back side. So that this side has the crystals, the back side, we see that those crystals are growing on a piece of rock. Dolomite is always associated with limestone. It's going to grow near it, it's going to grow on it, but it forms in the same area that limestone is formed. So as I mentioned, limestone forms from calcite. Limestone only forms in warm tropical waters. So if you find limestone and you find dolomite associated with it, you know that at the time it formed, which may have been millions and millions and millions of years ago, that location was warm and tropical. Now it also means, and I forgot to mention this about calcite, I forgot the other special property. The other special property is that it reacts with acid. So this is how we're going to distinguish the limestones. So you have dolomite. Calcite is the mineral that actually reacts with acid. So what happens, and I know you're not going to be able to see this on the video, you all have spilled soda, any kind of soda, on a surface, and you see how it bubbles when you spill it. Well, that same reaction is going to occur when you put acid onto calcite. It has this bubbling effect, and it foams up. You might be able to see a little bit, and it'll go away pretty quickly. Always wipe off the acid, because what's happening, it's eating up the mineral. So you're going to wipe up that acid. But anything made from calcite is going to react. Now, dolomite does have some calcite in it, but dolomite has other minerals too. So it does not react as strongly as just pure calcite. With dolomite, a lot of times you're going to have to scratch it with a knife and then put the acid in, and then you'll get a little reaction. It won't be a real strong reaction. As opposed to if I put acid on the limestone on the back, that's going to foam up and it's going to have little bubbles, lots of little bubbles. So the limestone will react because it's dominantly calcite. The dolomite is going to have a small reaction. And again, that's due to the calcite that is in that mineral. So the dolomite that I've got, again, we have the pink crystals. They're small pink crystals, kind of a bladed crystal habit. They're usually on top of limestone. The next mineral on your list is olivine. And olivine technically is actually a group of minerals. Olivine comes from igneous rocks. So you're going to find this around other igneous rocks near volcanoes and granite, you know, other igneous locations. And it contains a lot of apatite, which is a type of green mineral. And olivine in particular is a conglomeration of different minerals, but the key thing is that it is green. Olivine will always be green. It might have a little yellow cast to it, because again, it's a mix of minerals, but the dominant color will be green. This will also scratch glass. It is hard. Most all igneous rocks do scratch glass because they all contain very high amounts of quartz. They also do contain some calcite, a lot less, but very, very high amounts of quartz are in all igneous rocks. And so these will definitely scratch glass. So that's olivine. So think of green olivine. Okay, then we have our feldspars. So on the feldspars, if you were to be asked what the crystal habit was on these, well, you know, we don't see the individual crystals. These are massive. So again, these are found in igneous rocks. And so those crystals in igneous rocks tend to be interlocked together. So they're in that giant massive form. They don't have room to grow into nice individual crystals. So you're going to see just big chunks of them. And so what we have, feldspars are one of the most common minerals on the planet. And they make up a lot of different types of rocks, dominantly your igneous rocks. Granite is an excellent example of being composed of different types of feldspars. So the potassium feldspar, I already mentioned it, it has a pink color to it. Again, as you handle these, the color can change a little bit. So on a fresh piece of the feldspar, and if you're out in the field looking at granite, and you take a rock hammer and break off a piece of fresh rock, you're going to see the color in the fresh area is going to be different than the color that has been exposed to weathering, or in this case, to handling. But typically weathering, when we have a lot of rain falling on any mineral, that can change the color of the rock, because again, you're introducing new atoms to that mineral, and sometimes the mineral will accept those atoms and it can change the hardness and the color of the rock. So on the potassium feldspar, we're looking for something that's kind of a pink salmon color, and it has these little veins that are inside of it. They're just little squiggly lines that are all inside of it. And then on your other feldspar, your albite feldspar, this tends to be white or gray in color. You will see some flat crystal planes on there. So in some cases, if the flat surface is flat enough, it may be vitreous. Overall, these tend to be more dull. You may also have some other minerals combined in. Anytime you have a massive crystal, you have other minerals that could be combined in. So this particular piece of feldspar also has a little piece of muscovite in it. So there's a little piece of this muscovite crystal that's embedded in the feldspar. And your samples are going to be like that. They're going to be natural chunks of natural rock. So there may be a combination of minerals. You're going to look for the ones that are most dominant for that particular rock. So if it's a rock and it contains multiple minerals, it's a rock. If you have something that contains only one mineral, then that whole thing is just a mineral. So that feldspar is going to be white to light gray in color. These tend to be a hardness kind of mid-range, like 5.5, 6.5 in that range. They probably would not scratch glass. Again, you have to be really careful and make sure that you try and pick a corner that is not quartz when you're scratching. So you may want to try multiple sides if you're doing the hardness test for these. Then we have pyrite, and I already talked about that a little bit. Pyrite is known as fool's gold. A lot of people find this out in nature and they get all excited because they think they found gold, and it's not. First of all, pyrite's much harder than real gold. Real gold is very soft. It's as soft as talc, and if you actually do find real gold, you should be able to just literally press your thumb into it and it will mold. So real gold is malleable, and that is why we add other metals to it to harden it up to use for jewelry. Real gold is very, very soft. Pyrite is not. Pyrite is much harder. I don't remember if it scratches glass or not, but it would definitely, a pocket knife, it should be able to scratch, and you definitely cannot scratch it with your fingernails. So it's much harder. It contains high amounts of sulfur. And it also has particular crystal habits. So this is a more massive form, but once in a while, matter of fact, if you go on Google, you can see perfect crystal habits for pyrite, and you'll see that it can have a cubic form. It's very beautiful when it's in that form. And then the quartz, I already mentioned to you that we have lots and lots and lots and lots of different varieties and colors of quartz. And all of these are different types of quartz. It's the same mineral composition. Typically, in order to change the color on any mineral, and this also includes diamonds, it just takes 1 or 2 atoms of a different element, and that can change the color of the entire rock. I'm actually a certified diamond grader with the Gemological Institute of America, and I worked in the fine jewelry industry for a number of years. And you know, diamonds, just like quartz, come in any color of the rainbow, any color. Although I have to admit, some of them that you see on TV, like the teal color, that's not natural, that's been enhanced. And definitely, if you have a chance to see a green diamond or something that has a lot of green in it in diamonds, like the teal, don't wear it. The reason a diamond is green is because it is radioactive. So do not ever wear a green diamond. And then the last one is talc. And I wanted to show you talc and another mineral. I've already mentioned these. And actually I'm going to compare it to a third, my piece of chalk. So these are both minerals. This is actually a rock, considered a rock. So chalk is natural, just as these are natural. So the talc is actually forms under a metamorphic process. And so talc will often, you might be able to see layers in the talc. So the crystal habit tends to be a layered crystal habit. And it is very soft, so you should be able to scratch it with your fingernail. But you know what? It's not so soft that it powders. It doesn't come off on your hand. Now, as opposed to this mineral is called kaolinite. I can write with it on the chalkboard, but it's not chalk. This is a clay. Clay is a sedimentary rock that, well, clay is a mineral in and of itself, but when it's formed together to form a rock, it's considered a sedimentary rock because it's composed of particles that are cemented together. So this is kaolinite. Kaolinite is actually used in a lot of fast food milkshakes. One in particular that has arches in the past has used kaolinite. There's nothing wrong with that. It's actually a thickener, and it's also used in medicine. So like kaopeptate, that medicine to soothe your tummy, that's what it's made out of. It's got kaolinite in it. And so it doesn't hurt you to eat it, but it's a natural additive that is used for medicines and some food products for thickening. Just to let you know, we'll get to this in sedimentary rocks, but chalk, I don't know if you'll be able to see this, but just to give you an idea, if I use my hydrochloric acid on the kaolinite and the talc, nothing is going to happen because there's no calcite in them. But when I use it on the chalk, you can see it really bubbles up. Well, that's because chalk is a very particular type of limestone, and it actually forms in the ocean, and it's composed of the little tiny skeletons of diatoms and the little tiny microorganisms, both plants and animals, that live in the ocean that have shells that are made from calcite. So these are the little dead bodies of little microorganisms, and that's what we use for chalk. So that is the basics on how to identify minerals. Oh, I missed one. Missed one for you. It's on your list, and that is gypsum. I did show it to you a little bit already. So I actually have 3 forms of gypsum. And so these are all different forms of gypsum. Each one, this one kind of looks like lots of strands. So this is called satin spar gypsum because it has this look of strands. Gypsum is actually used to make drywall. So if you ever are helping someone with drywall a house or anything, this is what drywall is made out of. So it says the satin spar gypsum has strands. Then we have this type of gypsum, which is layers. So this is layers. Again, it's very clear. You can usually see through it. Very, very soft. So it's scratched very easily. And this is called selenite gypsum. And then this particular gypsum occurs in really dry, arid places. And this, you actually see the individual crystals. These are commonly known as a desert rose, but this is another type of gypsum. All right, so those are some of your basics on how to identify minerals, and I hope this helps. And I'll see you in the next segment. Even though you don't have igneous rocks that you're going to go over, I'm going to give you a little segment on igneous rocks, just so you have an idea of how those are classified too. See you in the next segment.